This
Slide.
conference will now be recorded.
Hello, everyone, and welcome to today's Critical Issues call on what's the future of the human-machine relationship. I'm David Brosell, co-founder of the Manufacturing Leadership Council, and here's our agenda for today. I'll give some opening remarks and then introduce our expert panel, Janice Abel from ARC Advisory Group and Dr. Jim Davis from UCLA, a longtime member of the MLC. Then we'll go through each of their presentations, and after that has concluded, we'll do a question and answer session with you, our audience, and also take comments if you have some comments about how you're thinking about the human-machine relationship in your own company. Our meeting format is pretty standardized by now for critical issues calls and other MLC calls. We have an audience consisting of MLC members, some NAM members, and guests that we've invited to attend. We'll keep everybody on mute until the end of the presentations, and then we'll open it up, as I said, for the question and answer session. We like these to be as interactive as possible, so if you have a question, you can put it in the chat function at any time. We'll take it later. But we do like you to participate as much as possible, so don't think there's any questions that may be too basic or too complicated to ask. Just ask them and we'll try to get to them. I may call on selected people on the group today, as is my usual practice. And we are going to be recording this and posting it in the member portal of the MLC website within a day or two after this session. Next slide, please, Leslie. A few pieces of information before we get started. Those of you who are regular attendees on these calls notice a different look and feel on the slide deck. We have just launched on June 30th our new website, and with it a new Manufacturing Leadership Council logo. As you can see on this slide. If you have some time, please go to our new website and take a look at all the improvements that we've incorporated into it. The navigation is easier. We have more information surfaced on the homepage in terms of news, upcoming events, and you will also see that our branding is now much, much more in line with our parent organization, the National Association of Manufacturers. So we invite any comments or feedback you might have on the new website, please let us know. So also in the field now, and I'm sure you've gotten a couple of emails about this, we are fielding our new M4.0 data mastery survey. We need your input on this. It's very, very important for the council members, for our own level of knowledge and intelligence about the data question that everybody is facing. Much more larger volumes of data everybody is experiencing in their more connected manufacturing environments. But as this has been said, data is the new oil, and the better we are at mastering data, the more advantages that can accrue to us. So please take that survey. We need your insights. We need your input into it. Next slide, Leslie. So now to our topic. And before I introduce our panelists for today, a few words about the subject, what's the future of the human-machine relationship? It may be a bit of a stretch to call what transpires between a human being and a machine a relationship, but that's the phrase we use. You can also think of it as what goes on as a set or series of interactions designed to extend or augment what a human being can do, or in other cases, do things that a human being can't do at all. Historically, humans and machines have interacted for centuries, largely on a physical level, performing labor and time-saving tasks that enable the expansion of production, the improvement of quality, and faster speed to market for products. As a result, the nature of the interactions has been largely that of master to servant, in which the human directly controls what the machine will do and when it will do it. Over time, the relationship, I'm now going to be using that term, relationship, has moved from where the human would use informational displays to control a machine to a model where automation enables the machine to operate a predefined set of instructions. But the rapid pace of technological advancement in fields such as artificial intelligence, sensors, and robotics is now making it possible for machines to reach a level of intelligence that will enable them to operate without predefined instructions, thus becoming what some scientists and researchers call non-human autonomous agents. And so the nature of the interaction, the relationship, is poised to change yet again. In manufacturing, it appears we are moving to a human-machine paradigm where labor cost arbitrage could lose its dominance. Instead, the paradigm will become much more symbiotic, and the relationship between human and machine much more cooperative rather than master-servant. What are the implications for such a change? Today, we will attempt to address some of the issues that are part of this question, such as, are we already experiencing a paradigm shift in which humans and robots have learned to work together in a relationship between what are admittedly unequals? Will the growing relationship between machines and humans enable manufacturers to change production and assembly line paradigms for the better? How should today's workforce prepare to work with increasingly intelligent machines, including collaborative robots? Here today to help us sort out some of these questions and perhaps even raise a few new ones are Janice Abel of ARC Advisory Group and Dr. Jim Davis of UCLA, a longtime member of MLC and a member of the MLC Board of Governors. Let's start with Janice. Janice, the floor is yours. Can't hear you.
Okay.
Now we can hear you. Go ahead.
Thank you, David. Hello, everybody today. Today's topic is on reimagining human-machine relationships. And I don't know. Okay. Does it change my slide? For some reason. Okay. And so my name's Janice Abel, as David said, and I'm a principal analyst with the ARC Advisory Group. And so what I'd like to do is just tell you who ARC is in case you don't know or you're not familiar with us. And we were found,
a little too fast.
Yeah, we were found, I'm just getting used to this switching here thing. We were founded in 1986 and we're focused on operations technology, industrial Internet of Things, research in smart cities, and we do a number of areas of research, and these are just a few, and you can go to our website if you want to see more. And we have a global presence in around the world. We also do both end users and suppliers, and these are just a few of our clients, and there's more if you want to look online. So the digital transformation is really about people and workplaces, data and information, processes, places, and things. And it's really about new business models and the transformation of business, industrial products, operations, value chain, and services that are enabled through the augmentation of people, knowledge, and the expanded use of digital transformation. I think when you talk about the human-machine relationships, you need to think about the digital transformation because it is about the digital transformation. And so what I'd like to do is just talk a little bit about what we are seeing. And so the human-machine relationship, where it's going in terms of manufacturing and operations. And it's really about, we're seeing self-driving cars, and that's just an example of a machine that is doing what others are doing, like artificial intelligence and machine learning. And so where is this relationship going, especially in operations? And so what we're finding is that it's really going more and more autonomous. And so what we're seeing and we're hearing about these lights out manufacturing and autonomous operations. And so that's really important, I think, to keep in mind. Although some people claim that there will always be people on site. And so the human-machine relationships really is about the connectivity, and it's about connecting aging systems and old work processes. It's about all these newer disruptive technologies that we're seeing, like robotics and digital twins, digital threads, predictive analytics being connected. And it's really about having connected operations, connected supply chain, and more. And so the challenge is the digital transformation in machines is that people, data, and machines need to be connected and interconnected. And we need to have aligned thinking of collaborative minds that are distributed across the globe and really together. And without that connectivity, interconnectivity, none of the benefits of the digital transformation can be realized. So the other thing about the human-machine relationships is we're seeing different levels of automation, really, and really autonomous is an extension of automation. The automation systems that we started seeing in the early 80s and late 70s, early 80s, and growing up to the semi-autonomous to actually completely by themselves autonomous. So really we're seeing more probably semi-autonomous where people are working with machines. But we are starting to see even autonomous vehicles. Like even with drones, I consider that really semi-autonomous vehicles. We're seeing warehouse robots that go back and forth, and they're pretty smart. We're seeing a lot in the mining industry, which are like driverless vehicles that are doing the mining. We're seeing underwater vehicles. We're also seeing things being used, conveyor lines and other things. And what we're seeing is they're replacing repetitive, tedious, and even dangerous tasks. They reduce errors, and they do enable humans to focus on other areas of operation. And so robots really are enablers for autonomous operations, and we're seeing them in all different uses. A lot of them have like a specific functionality, like collaborative robots in manufacturing, drones, transport organizations for both underwater and other vehicles. So we're also seeing immersive augmented reality, and that's really more about the visualization and enhancing that visualization like with humans. So they are working collaboratively with humans, like for standard operating procedures or for work instructions or for assembly and other visualization and part identification. And so the other aspect to this, and this is very, very important, and I'm sure everybody knows this, but you really need to align the culture with the technology. And it really does require collaboration and working together of the people, the culture, the technology, the business, and the workplaces. Because the reality is, and this is really important, I can't overemphasize this enough, the culture really will determine how things get done. And technology and the people will help to drive that culture and innovation. And where this is important is really people ask often, well, how do we align the organization? Do we do it from the top down, the bottoms up, or somewhere in between, or from all aspects? And I think it should be from all aspects, but the key, the top is very important, where the key is going to be to work together to bring people into the relationship. And often, and I've talked to several people about this, and especially this friend of mine that I've known for years and years. So he told me in confidence, and he's a very large global manufacturing company, and he's head of one particular organization in that thing. And he said to me, he said, the thing is, corporate is often perceived as governance and rules. And so that perception is really important. And he said that often he thinks of corporate as, hey, we're from the IRS, we're here to help. And the reality is that you need to get everybody on the same team. You need to align these people, and you need to use a lot of change management in order to make a lot of these changes. And you also need to consider some of the moral aspects, and we'll talk about that in a minute. But we're already experiencing, I think I went too far. Okay. We're already experiencing a paradigm shift in which humans and robots have learned to work together in a relationship between unequals, where we're seeing robots and cobot usage increase. Last year was probably not as high as we believe it will be over the forecast. We saw a CAGR, because we do this research and we look at the markets, of 3.2% and ARCs for robotics and 4.2% for cobots. And we believe that this will increase substantially over the forecast period as well over the next few years. So you're going to see it a lot higher. But we do believe robots will achieve higher throughput and efficiency, and they will continue to augment and collaborate and even replace human capabilities, like we're seeing with the cars, and like people will use augmented reality instead of cameras, where it works better, at least initially. And then for operations, we're seeing more in the discrete, the use of robotics and machines, but we are seeing robotics being used in raw material movement, the filling lines, dispensing, and some other things, as well as the unmanned vehicles, like in the warehouses where we first started seeing it, but now we're seeing it actually in the manufacturing processes. But they are much faster and more efficient, and they do increase productivity. And one of the things that caught my eye was Elon Musk. He was asked not too long ago about why the push when he's probably one of I think of him as a very futuristic, forward thinking. And his thing was he wanted to be autonomous for the Tesla, and not only would the Tesla be autonomous, but the factory would be autonomous. And so he was asked about the assembly lines, and he said the assembly line robots just couldn't deal with the unexpected orientations of objects like nuts and bolts or complicated maneuvering between the car frame. And part of that was because they don't have the sensors, I think, that they need right now. Their vision is limited. And so his result of this, he said humans are underrated, which may be true. You know, there are functions that I think humans can do much better and robots will never replace. Okay. I have the controls, but it's not switching. Okay. So, oops, we went too far. So, will the growing relationship between machines and humans enable manufacturers to change production and assembly line paradigms? Well, I do believe that it is changing now, and that robots will eventually replace all repetitive and hazardous tasks that are driven by AI and ML, especially where it makes sense from a cost standpoint. And it's really not that different from automation systems today. It's really more of an extension of an automation system. And the thing is, robots and machines, they don't take breaks, they don't go on vacation, they don't get sick, and they don't need climate controls. And also, robots and machines learn from the data, but they don't think. They can only be as good as the data in the context of the data that they're given. And robots are just not as flexible, nor is their vision as good as humans. But I do believe that humans have the creativity and innovation that machines will never have. And they also have the dexterity and the vision. And so the challenge, of course, is the moral dilemma, and it's the risk of losing jobs. And if you look here, the red is more or less skilled labor for the most part on that chart. But I know you can't really see it that well, but it's really repetitive jobs, and the lowest skilled jobs are the most replaceable. And you can see that other countries, you know, the United States, if you're in the United States, is way behind. Like, I believe this is Singapore and Korea are the top two poles there. So they're already on this path, but I think other countries will catch up. And also labor unions. I sat on a plane next to one of the heads of the Teamsters a few years ago, and I'd just come from an autonomous automation meeting. And so I asked him about, you know, drivers being replaced in the trucks by the labor unions, and he said that they will. He was pretty much in denial. You know, they're going to fight it. And so that's the thing, is there is a dilemma here. You need to reskill employees to do other tasks, and they can do other tasks. They can do maybe things about doing things better, or better products, or maintenance on the robots, although in the future it might be the robots maintain the robots. But one thing that struck me is that there's some people that said that there'll always be people on site. And in some plants that may be true, but I think somewhere, maybe 20 years in the future, maybe longer, that there will be more, almost all plants will be autonomous. But if you look at this book, it was by an MIT and Harvard economist, and they argued in 2004, which was 16 years ago, that a computer would never be able to drive a car due to the complexity of the information involved. And we know this is false. There will be autonomous vehicles for cars, trucks, planes, and they will replace professional drivers. And we're going to see that very soon, and we're already seeing it in some places. In fact, in Boston, there, which is where I'm from, they're actually going to have driverless trucks. So that's already in the works. So how should today's labor force prepare with the increasing collaborative, even sentient robots? Well, they do need to reskill with training, and they do need to retrain them for better jobs, and they do need to have collaborative technologies like autonomous machines, cloud, augmented reality, and really anything that makes the workers' lives better and their jobs easier. Okay, so for some reason, it won't let me trade. I can't change the slide. Oh, okay.
Yeah.
So there really are a lot of benefits from humans and machines working collaboratively, from reducing labor costs to reduction in human errors to increased production. And next slide. And so really what's essential? Well, it's essential to invest in newer technologies, robotics, augmented reality, the digital thread, the digital twins, and more. And it's also essential that you invest in the worker innovation and creativity, and also have that cultural alignment that I spoke about, because human machine relationships are changing. And this requires that companies work with their employees to help establish new skill sets, better data and information, connectivity and interconnectivity and collaboration that uses robotics and other newer digital technologies that enable humans and machines to reach those new levels of innovation, creativity, and competitiveness. And so, next slide. I'd just like to thank everybody. That's pretty much the end of my presentation. And you're a great audience. And back to you, David.
Thank you, Janice, and a lot of food for thought there. I'm sure we're going to come back to talking about your vision of all plants being autonomous going forward, and I'm looking forward to that discussion. Audience, if you have questions or reflections, comments about what Janet has just gone through, please put them in the chat box. We'll get to them during our Q&A session, but for now, I'm really pleased to turn it over to Dr. Jim Davis from UCLA, who will give his perspective on the evolving human-machine relationship. Jim, the floor is yours.
All right, Dave, thanks very much. And Janice, thanks very much. It actually has worked out very, very well to follow you. Many of my comments will be of a very similar nature. Janice, one of the things you said at the beginning was if we don't have connectivity into connectivity, the benefits will not be realized. That's actually pretty much the subject of what I wanted to talk about, and would like to take pretty much a macro view. And when I look at this word reimagining the human-machine relationship, what I'd like to talk a bit is reimagining the human-industry relationship, because you actually have to have that in place, to get to the human-machine relationship. This is a little bit of a busy introduction slide, but what I wanted to do here is basically point out that there's two major efforts I'm involved in which there are findings coming out, and very recent ones, which I'd like to pass along today a bit. The first, on the right-hand side, for those who don't know, there are 16 manufacturing USA institutes in the US. This represents a US investment in advanced manufacturing. One of them is the Smart Manufacturing Institute, which is sponsored by DOE. That's the one I'm involved with. But there's 16 of these that are all looking at this problem. And if you look at the memberships of these, and you could just use ours as an example, 130 members, manufacturers, providers, integrators, universities, all taking a look at this problem, and there's some results coming out from that. More recently, however, you see on the left-hand side, National Science Foundation, National Institute for Science and Technology Symposium. I wish we could find a different word, but if you look at the titles of these three workshops, it's not about the technology, it's not about focus on workforce, it's about bringing these together, and it's about asking some hard questions about manufacturing competitiveness, where does the U.S. need to invest, and what are some of the national priorities going forward? And one of the most interesting things on the left-hand side effort that's been going on as we try to answer these questions is the recognition that manufacturing is in many ways kind of insular if you look at other industries. And there's good reasons for that. But one of the things we try to do is bring in outside communities, other industries, and in particular the AI and machine learning community in the broader sense for some, call it broader and fresher views going forward. And just doing that has been really quite interesting. So I'd like to pass along some of the results from both of these going forward. Next slide. So basically, again, to what Janice had said, there is this whole matter of digitalization and Industry 4.0, smart manufacturing, manufacturing 4.0 have been around well over 10 years at this point. And I think the general consensus is that it's moved along, lots of stuff is happening, but the speed with which it's happened, the degree to which it has scaled has actually not met expectations. And so one of the things we're really trying to take a look at is what is this relationship and where does it need to go? And when we look at the human side of this, what does it look like when you get to the full potential, and then how do you get there? One of the things that we've learned is that the vocabulary that's being used out there is all over the map. Many words are being used to mean many different things. And one of the things I'd like to do is just very quickly go through the vocabulary I'll be using this morning, just to make sure we're all talking in the same wavelength, if you will. I'm not going to read through all of these, but I did want to call attention to the definition of artificial intelligence. Software systems that can recognize, simulate, predict, and optimize situations and so forth. You'll see that the definition that we've been using through the workshop and through the institutes, have been outcomes based, and we're not getting hung up on a very precise technical definition, nor all the different technologies that are involved with this. Also want to call attention to networking. This is the word we're using. Janice used the word interconnectedness. And one of the things that is coming through loud and clear for advanced manufacturing is, we talk about networkings, but we're really not interconnected and we're not really leveraging connectedness. And one of the big effects here is this last term, network effects, is that if you are interconnected, there's many more things we can do to build up the base as a result of being connected. And this is also one of the major areas that offers a huge amount of opportunity that we've really not tapped into. Obviously, predictive modeling is the holy grail. Next slide. We needed a reference point. And so this can be debated. Love to hear comments on this. But our reference point that we chose was manufacturing competitiveness. What exactly does that entail? The left-hand side is the view of what we consider to be the priority converging drivers. And by the way, when I say we, I'm talking about a large base of manufacturers, government folks, university folks, and so forth. But you can see that global leadership and operations, and you'll see these words: precision, productivity, and performance. This is the money side of it. This is the market side of it. This is the leadership side of it that has to be in place for anything to go forward. So we're really questioning and asking, where does digitalization take us on the economic side? But we also have these other things that are critical and have actually risen in, call it value or value propositions. There is the environment, there's the consumption, waste, sustainability, climate change, carbon intensity, they're all increasing. We have a lot with this pandemic around national security, dependence, and obviously cybersecurity. Those kinds of things are hard to go after in a straight up economic fashion, but we do have to make them economically viable going forward. So manufacturing, right-hand side, this is how we define it, and that's our reference point for putting priorities together. Next slide, please. So very quickly, I'd like to talk about what I just mentioned as the money makers as we're looking at it, and I'd like to use some old legacy kinds of technologies to illustrate. The first word here is performance, or asset performance. And one of the things we're seeing is that there are, in some places, ways to actually drive the performance of a particular unit up. The reason I'm wording it this way is you can look at many unit operations and they've been optimized to the hilt, but the question is, can you do something different to drive up the performance? Here, what you're looking at is a steam methane reformer. In this particular case, it's Praxair Linde Port Arthur, Texas unit. And you can look at the size, the industrial scale, and it's a very, very simple concept. The industrial scale furnace, it's very difficult to keep the temperature distribution inside the furnace even. And because it's not even, you have to keep the temperatures lower to avoid hot spots and burnout of the tubes. So if you just do something simple in terms of level setting the temperature, and this is what we're showing on the right-hand side, you can raise the temperature, the efficiency, and the hydrogen production goes up. And this was actually accomplished with infrared cameras and using this kind of newer image technology with the modeled systems. But what you've done in this particular case is you've now increased the equivalent of 280 temperature points, producing 280 data points every 6 seconds, averaged over 1 minute, running 24 hours a day. And you have to work with quite a bit of data, but this could be done. But again, this is what we mean by performance. Next slide, please. By far on the operations side, we're seeing the headroom on the economic side in the category of bringing precision, performance, and productivity together. So what I'm looking at here is just a metals fabrication shop. You have a forging press, heat treatment, and an entire machine bay of machines to make the final part. But if you focus on the forging press, look at that part quality at that point that's being pressed out, and worry about that, worry about the part quality going into the heat treatment. Then you worry about what the heat treatment is doing. Can I maintain that part quality, get the hardness that is desired, and reduce effects and reduce the number of destructive tests? I'm making great strides. If I can go into that machine bay and really worry about how I use those machines in the best possible way for the highest production volume, given a whole range of parts coming out. So this is an example of focusing on the part quality. And to focus on the part quality, what I can do is start doing some measurements, integrating models, integrating across these different units. I can reduce idle time, I can reduce defects, I can manage the heat better, I can reduce defects, maintenance, energy on the machine bay. And when I put all these together, I'm looking at 15 to 20% economic benefit just by this integration. This is what we mean by productivity or the interoperability. Next slide. And then try to do this very quickly. We all talk about, there's a lot of discussion about supply chains out there. The bottom sort of yellow is a rendition of General Mills supply chain, Cheerios. And if you look at this in terms of the front end, if you can just simply buy Cheerios, buy higher quality, make sure it's qualified, it's GMO free, it doesn't have contamination, and so forth before it even gets to the factory, in this particular case, Minneapolis, the savings is tremendous, and you can avoid a huge amount of inventory sitting idle and possibly having to be thrown out, and the energy and the energy and production savings is tremendous. We've had this pandemic that's gone on. If you look at the blue, that's actually a rendition of Johnson & Johnson and what they had to do with Tylenol. The gray is Procter & Gamble and what they had to do with Vicks Vapor Rub. And what we're showing there is that if you look at General Mills, Johnson & Johnson, and Procter & Gamble, those supply chains intersect. So we actually have this situation of supply chains that are highly curated. And if we could just have them more visible and have the analytics more industry-wide across supply chains, you get at this question of resiliency. So what I'm trying to do with this slide is distinguish between supply chain productivity and then supply chain resiliency in the form of visibility and analytics. And you can see this kind of information on the right-hand side that gets at that. Call it the digital supply chain. Next slide, please. So one of the things that we look at from an economic standpoint is how do you bring the money makers, performance, productivity, precision, when they are existing from end to end, and then what can we do with these? From a institute standpoint, we're obviously looking at workforce development, we're looking at infrastructure, and we're looking at the building blocks to take these forward. But what we're really going after is, again, this performance, productivity, precision as I defined it. But there's outcomes that come from this: improved productivity, reduced waste, yield, quality, track, and trace. And what we begin to see then is reduced energy, reduced material consumption, improved environmental sustainability, and so forth. And these are now within the context of economic benefits going forward at a rate of about 15 to 20%. Next slide, please. And if you start adding these all up, if you look at this middle column that basically says energy and energy improvement or economic improvement, and we look across these industries, what we did was take a look at line of sight, what we call economic reachability, just with respect to performance, precision, and productivity. And if you look at the operations column, you see that these benefits are largely coming through line operations, through supply chains, and to some extent performance. And it's just simply, even with the legacy operations, if we could get the data, the right data, the curated data, the right sensing and the right technology in the right place in the right hands, we can have, there's just a huge benefit going forward. So the headroom on this, the benefits, the economic benefits are really quite large, as well as the outcomes that we can expect. But next slide. Probably this gets to the guts of what I wanted to talk about with respect to the human side of this now, and this will mirror quite a bit what Janice had said. So AI, in the definition I talked about, the hard part about it is you need to bring the knowledge and the data, curated the data, the right data together. But if you can do that, it holds a huge promise for cost effectiveness. But the ease of implementation, the lack of generality, has stunted this implementation. We're really quite stuck somewhere closer to Industry 3.0 than Industry 4.0 when it comes to putting these in. So one of the questions with respect to this relationship is, how does I free this up? The second one is particularly important. What matters here is the right data, and the right data in the right context. And if you can get more data, you have more powerful solutions. But we as an industry tend to want to work at the factory floor or within our own sort of boundaries at the factory floor, or even at unit operations or line operations. And that's not going to get us there. We don't get the right data. There's actually very few manufacturers that are able to generate enough of the data to get it where it needs to build these algorithms, these sorts of autonomous sorts of operations in the way that is needed. So this ability to access the right data, share it, and I use sharing in a very broad way, with trust is a prerequisite for getting to these digitalization impacts. The third one, we all talk about it, but it's the question of how do you really get there? Small and medium manufacturers are critical to this manufacturing ecosystem, and they are in fact also huge sources of data. So how do we get data from the small and mediums? How do we engage them? And then how do we get the benefits back to them? Even if I look at the General Mills supply chain, there's about 4,000 small and medium manufacturers that are bringing those oats, to the manufacture of those Cheerios. So one of the things that's really missing in action here are the tools and the ability to discover these sorts of capabilities in a secure way, access them, and then bring them to bear on these solutions. So what we're seeing is a large missing in action with respect to the people and the relationship are the tools that go after these kinds of value propositions with respect to sharing data. And then there's some really important relationship aspects that we've again talked about. The MLC has talked about these quite a bit, but making headway on these is really quite difficult. Manufacturers are reluctant to share intellectual property, and then there's a huge amount of concern about risk with unintended consequences. The question is, where do we get a new definition for this? How do we recalibrate the IP? We've, as an industry, have grown up with this kind of perspective, and it hasn't hurt us so far because we haven't needed to really share. But now, in a digitalization sort of perspective and a relationship, the data is now worth something. So we need to get there. So I put this here: the IP needs to be recalibrated beyond just the views of the data. It needs to be recalibrated towards these value propositions. And there's a lot of ways now to share data. It's not just sharing it and pooling it and making copies and so forth. These all need to be brought to bear. But the relationships become important to do that. Manufacturing has grown up. If you look at the code, if you look at how the applications have been built, it's actually quite difficult to separate the data from the application so that it's reusable. And so there's actually new ways we need to think about building out the code and the applications going forward, because basically what we've done is trap the data, let alone being able to share it with trust. And quite frankly, the marketplace right now, which is a huge relationship between the manufacturers and the providers, the vendors, systems integrators, universities, just is not set up to drive these kinds of things. So there's a big relationship question about the market and then driving, just the pathway here. So this gets us to this notion of an adoption cycle that has emerged from these recent discussions with these new views coming forward. So the next and last slide for me. So one of the things that's come out of bringing together these groups and looking at actually how do we do these things, if you start looking at this, you start seeing artificial intelligence for the factory floor. We talk about this, Janice just talked about this, and you start seeing this, we start seeing this quality assurance being one of the primary hard dollar things to go after, and then asset managed follows between the two. So it's under many terms, predictive maintenance and so forth, and then obviously you have to get information to people for this. But if you ask the question, if I'm going to focus on the factory floor, how do I get to these supply chain kinds of effects, this interoperability, this coordination? And there has to be some additional opportunity opened up. And we begin to think about new markets for the data and the methods themselves, not just for the products and the technologies with which products are manufactured. And so this gets us to, well, how do we get these two brought together? And again, a lot of discussion, but under this heading of artificial intelligence for industry-wide data sharing, there's lots of interest in the interoperability, but we need this infrastructure for the digital side of this, but we need to open up the IP, and we need to have these ways that drive the power of the data. This is the interconnectedness and the network effects that I was talking about. But we also need to be able to scale, and this is one of the toughest problems of all. We've done this to some extent with CAD and with some systems designs, but we needed to do it more broadly. So how do I get AI domain expertise application capabilities in a pre-competitive way shared so that these can get in the hands of the small and medium manufacturers as well as the large? And what this really is basically saying is we talk a lot about workforce development, but what about upskilling with the tools in place? We are not really talking about the right tools in place. Let's get the tools, upskill with the tools so that we're going after the benefits, which then begets the tools and the upskilling that we need to go forward. And so you begin to think about bringing all four of these together into, we call it a virtuous cycle. Start at the factory floor, generate some data, get it shared, get some benefit at the supply chain, use the supply chain to start driving the scalability, and then bring us back down to the factory floor and the benefit and just get that going. This is why we talk about starting small, starting with some simple ideas and then moving this forward. But the main thing here in this relationship thing is we have to, as an industry and the people side of this, move into much greater environment of meaningful shared data, much more scaled versions and ability to get at tools and the applications. This is going to require this interconnectedness and trust, network effects. These are all starting to happen. And my own particular vision on this or word on this is optimistic, but we're at an inflection point. Do we really want to accelerate, or are we going to continue the relationship we have in the past, which will result in more of an incremental approach to all of these? I think that's the question on the table with 10 years of looking at this stuff across Industry 4.0, smart manufacturing, and manufacturing 4.0. But David, back to you. Let me stop there. Hope that provokes some thought.
Thank you, Jim. That was not only food for thought, that was a feast for thought. Lots of important data points and lots of questions too. Let's now go into our Q&A session with the audience. Leslie, have any questions come in through the system?
Hi, Dave. I can help if you wish.
Yes, Paul. Any questions come in through the system?
Yeah, Al Campbell has one. In fact, there are two or three which are kind of grouping around a question I was going to ask Jim as well. But this, Al, can you unmute and do you want to ask your question directly to Jim? I think this one's aimed at.
Right. Yeah. It's just Al Campbell with San Mina. You actually kind of went into it, Jim, kind of immediately after I hit enter, but I was asking what, when you look at the data that small and medium manufacturers need to get and give, what do you think are the most critical things for manufacturers to work on in terms of being able to share data with the supply chain, as well as to take data from the supply chain and consume it?
We're seeing a couple of things, so I'm going to word it this way, and then I appreciate reactions. So I'm really just recounting reactions from, it's more than reactions. We've spent some time with this question across several different groups. The obvious one is on the machine side of things, and if there could be data about the machines that could be shared, and what we're talking about is not data just about the machine itself, because that can come from the provider or the machine builder in a lot of ways, and there's room to play there. But it is basically that data about when the machine is used for something. Suppose you're working with aluminum, suppose you're working with a polymer or composite, and you're using machine for certain kinds of things. There is a lot that has been learned about how to use that machine with those particular materials. And if we could save and curate that kind of data around the use of that machine and have that sort of thing shared together with the vendor information, you can get at quite a bit more. We're seeing quite a bit of interest and quite a bit more use of that machine, better use of that machine, as well as ways to get at the quality of the machine, which is what the individual manufacturer wants to get at. We can also make the same kind of statement about certain kinds of processes. There's furnaces, certain kinds of material processes, and so forth, that are relatively common. And if we could just share some of the know-how combined with the curated data, we could take this forward. And then, Al, sorry, everything ends up being that you can talk for a week on it. The other place is the question of where do you build these algorithms? Where do you test them? Where do you benchmark them? And those aren't necessarily happening with the manufacturers. Those are happening within universities. Those are happening with other areas, national labs, and so forth. If there could be access to just some benchmark data with which to test these things out, for which the manufacturers could get hold of, that would be very beneficial as well. Just some examples though, but it's all around this quality and predictive maintenance as top priorities to start out.
David, Janice wanted to say a few words on this question as well, if that's okay.
Sure, please go ahead, Janice, please.
Yeah, so actually, this is near and dear to my heart, because one of the spaces I do at ARC is operational historians data platforms, which we're seeing, and you kind of alluded to this, but I think that the separation of the data, the manufacturing data, can you hear me?
Yeah.
Making sure okay. And so this is really near and dear to my heart, and I spend a lot of time on historians in the manufacturing space and the data and what's happening in the space. And we are starting to see these newer platforms, and we're also starting to see the cloud being a much bigger factor in what's happening with the data and the interconnectivity, and also this idea of end-to-end with the data and the digital thread, which is basically taking a set of data around a process or a product and going right through to the manufacturing process. So that's just a quick comment. I mean, I could, like he said, I could spend a month or a week on this. So it's a great topic, and it is very, very important. The data is so important, and being able to access and get that data in context, because that's a big part of working with machines.
Thank you. Paul, any other questions come through?
Yeah, we have another one from Kurt. It's also around that kind of data sharing question as well. Kurt Malone, are you able to unmute if you want to ask your question directly?
Yes, hopefully you can hear me.
Yeah, we
Yes.
can. Sure, go ahead.
Absolutely. So you spoke extensively around the importance of IP and data sharing to really accelerate progress here. But as you know, there's a lot of investment and values embedded in that data and IP. So I was really interested in how work is progressing, or is there examples out there of how data and IP is being shared within or across industries to help support advancement and growth?
Jim, that sounds like one for you.
I can certainly jump in on this one. So there's two parts to this. There's what data, and then there's how to share the data. I'll just mention very, very quickly, and again, it's one of these you can go into pretty deeply, but this data in context, there is a lot of data about how to do things. So I use data in a very broad sense, not just the telemetry data, the product data, and so forth, but even going back to that steam methane reformer, there's quite a bit of data about how that infrared camera data was contextualized just to bring it to temperatures. There's quite a bit of information about how that data was basically normalized and manipulated and set up just in order to read the temperatures. And that data is not so IP oriented, it's not getting at the process itself. And in fact, Praxair was willing to share that kind of data. That's metadata or data about data. With respect to the methods, we're seeing two, or perhaps three predominant methods that really are looking promising if we could get them in at scale. One is the notion of pooling data. That's the most common, and the notion of trusted data or data trust is building out, and this becomes the right infrastructure with which to pool and share data. And then you get into a whole set of methods, around encryption, putting together synthesized sort of data and so forth, for the benchmarking purposes and so forth. Another one that's very, very interesting is the notion of federated learning. And this is the idea of not moving the data around, but moving the models around. And the data stays where it is, but the models go where they need to be. They're built out, and then the models themselves are shared. That also looks quite promising, but there's new technical developments and understanding of that need to be built out. So quick answer on methods, and just making sure everyone understands there's many different forms of data if you tease this apart.
Janice, any comment on this one?
Sure, I can always comment on data, but I guess I'll just say real quickly that everything Jen said is true, but in addition to that, what we're seeing, and this is in the marketplace, we're seeing a lot of services around the asset performance, like you mentioned, and around even, especially during COVID, we saw tons of people sharing data because they had to, and they were relying on other companies in their ecosystem to help them repair things or help them even manufacturing or even to implement new technology. So we saw a lot of that in the last year, more so than I've ever seen in all the years. It really, I will say this about COVID, it definitely accelerated the digital transformation. And in that respect, I think more data sharing. And I had heard all those things around the IP and then I'm starting to see, because I also do the manufacturing execution systems, and I'm starting to see things around the sharing with the supply chain, as well as like recipe management, things that people said they wouldn't share before, or their lawyers said they couldn't. And even in some industries, like I do a lot around the pharmaceutical industry too, and the automotive industry, and some things that they said they would never share, they are starting to share now. And so there's getting, like he said, the trust is becoming a little better because they're getting things out of it, I think is the reason.
Paul, any further questions coming through the chat?
Not through the chat yet, but we'd like to welcome everybody. If you wish to put any questions into the chat box, please do so, and we'll bring them to the attention of our speakers. I do have something I'd like to ask as well in the meantime, David,
Sure.
if that's okay.
Please go ahead, Paul.
Janice, on your presentation, there was one of your slides I was kind of interested in. Where you talked a lot about the technology, but there was a slide that specifically identified kind of culture and people as being a critical factor in this process of the relationship. How do you actually practically go about changing people's mindsets to, first of all, be comfortable, and secondly, trust data in a way in which maybe they haven't before? Is this something that you need to actively train people to do? Is it something about incentivizing the workforce in order to be able to give them a reward for doing this? Is it something that's simply generational or will be an issue that will go away in the next 10 years?
Well, I think a lot of it is around, it's a trust thing too with your employer. I think part of it is just what I said, you're going to need to reskill employees. You're going to have to let them trust you that, we're going to replace some of your functionality. They're going to make your job easier, and we're going to have you do other things. I think that's part of it. And I also think you need to have an alignment in very good, what they call change management procedures, because when you introduce things, and I've seen good change management procedures and I've seen really bad change management procedures where they just say, this is it, you know? Whereas I think part of it is as you change technologies, it's actually a good thing to make the people that are doing the jobs part of the team that's actually going to, you know, help you to and put in the inputs from them to actually make, when they're part of the team, then they feel like they're going to do something. And they also see that the end game is, it's either going to make my job easier or I'm going to be retrained to do something else. And that's kind of the, like I said, it's a moral dilemma in some ways, because machines will replace humans. And there are less humans today in manufacturing plants than there were 5 years ago even. So it will happen. How long it's going to take, it's probably, it might be 20 years, it might be 10 years, you know, but I do think it was accelerated this last year.
Let me pick up on that, if you don't mind, Paul, and go back to something Janice said at the outset of her presentation, and that was around her belief that factories and plants will become increasingly autonomous in the future. Jim, I'd like to bounce that one over to you. What, do you agree with Janice on this? Do you think we're headed toward autonomous factories and plants?
I'm actually in violent agreement. I skipped through it. If you look at the economics I was trying to breeze through earlier, the investment potential for the industry is huge. And what we're seeing, if you run the economic models, that investment potential can go into very new jobs going forward. And one other thing I'll mention, I'll emphasize that Janice mentioned, and perhaps I should have emphasized too, the industry has a tendency to look at these kinds of things in a top-down manner. So it's OEMs flowing down to to small and medium manufacturers. But if you look at the other industries and these network effects and so forth, the bottom up played a huge role. Small providers, small companies, taking on new niche areas, working with data, building algorithms, taking this data forward and so forth, so that it could scale dramatically. This notion of network effects actually changes the equation dramatically, with many, many more companies, many more small businesses taking up the load on this going forward and pushing back up to the top. So I see this mix of top and bottom strategies playing out. Janice, I think you were saying something to this effect, which will have a dramatic change in what people are doing, but it also requires a huge cultural change for the industry as it currently is run.
I think that bell just said we are at the top of the hour and at the end of our session. So I want to respect everybody's time. I want to thank Jim Davis and Janice Abel for their insights today on our panel. This is a conversation about the human-machine relationship that will not stop here. We will certainly continue with this in the months and weeks ahead. It's an evolving topic and much to be learned about where all this is going. And just to alert everyone on the call, still on the call, our next critical issues panel will take place on September 14th. We'll be looking at what's next after M4.0. Next slide, please. I think Paul or Leslie. Next slide, please. And of course, as all MLC members probably know by now, we're launching a new event here at MLC later in the year called Manufacturing 2030. The shape of things to come. That'll take place in December in New Orleans. There'll be more information coming out on this in the weeks ahead. And until then, we look forward to seeing you all on a future Manufacturing Leadership Council call or event. I'm David Brosell. Thanks for joining us today. I hope this was relevant and useful and stimulating for you. Look forward to seeing you on a future call. Thanks. Have a great day. Bye.